Well, now I want to introduce Sherry Johnson. Sherry, as you know, owns Cat's Paw Company and just came out with the new product, InstraTrack. And Sherry is going tonight start a new series on our show about the new technology. Tonight it's about CAD, uh, what's available, and the different kinds of CAD that's available, and what can it do. Sherry, welcome. I really appreciate you doing this.
Great, thank you. Thank you for the introduction. And let me get my screen shared here. Make sure I'm doing this right. Um, and of course, it's arguing. Oh, it doesn't. Hold on here. I missed fixing one thing on this computer that I didn't do. Okay. Okay, are we sharing now? There we go. Okay, so it happens when you travel and you're not on your home computer. Okay. Um, and tonight, as Jim mentioned, we're going to discuss CAD, what it is, and what it can do. First of all, what is CAD? Now, CAD is basically computer aided design. It's software that runs on the computer, and it allows you to draw things, 2D images, 3D images, and basically you draw the stuff on a computer versus back in the old days doing it all by hand. And I just dated myself because when I took my first mechanical drafting course, it was on by hand. And that's actually a picture from my classroom. I actually found an old picture there. The one thing that you can never do with traditional 2D drawing and by hand is to actually create an object in 3 dimensions that you could rotate and look at, which being able to draw on the computer, you can do that with CAD. The other great thing is you can share CAD files easily. If I have drawn something on my computer, I can share that file to you across the country and you can open it up and look at it and go, hey, I don't like the way this looks. If that had been done by hand, I would have had to mail it to you or fax it to you to get input. So basically, it's taking something that was done traditionally for years and years and years and moved it over to the computer. Which brings me to my little history lesson because I had to throw this in there. CAD has been around since the 1960s. It ran on large mainframe computers, had specialty workstations, and back then, CAD was short for computer aided drafting because all you could do was basically, mechanical drawings, which was considered drafting. 1982, let's see, IBM had already released their desktop computer. Autodesk came along and said, you know what? We need a drawing package for the masses. We need something away from the mainframe and something that the everyday user can start creating mechanical drawings. 1982, AutoCAD came out with Autodesk, or Autodesk came out with AutoCAD, rather. And as we say from there, it's history. Back in the 82, you still had to have a special operator because it took a lot of training to use to figure out how to use AutoCAD back then. It was not very intuitive. I remember during that mechanical drawing class, I had one assignment to use AutoCAD. And I was happy to go back to my drafting table. The late 80s, early 90s, we started to see more software come out there, more things become available where you could do 2-line drawings, you could do 3D modeling, you could edit photos. And that's when the description of CAD changed from just drafting to computer-aided design. So now CAD kind of encompasses anything that you can design on the computer, whether it's animation, virtual reality, 3D drawings, 2D drawings, your specialized software for designing model railroad layouts. That all now falls under the heading of CAD and computer-aided design. Not only with the advancement of that, the software, the dedicated CAD software, has the option where you can export files so that you can use them directly or with a couple of other steps you can use the items that you've drawn on the computer to run a 3D printer. So you can draw something and send it to the printer to print. You can draw something in CAD and send it over to a laser printer to have it laser cut, or to a CNC machine where you can have it milled. So it took out the part where somebody drew it by hand, then somebody had to figure out how to mill it. You can now go from one step to the other with just the CAD software. Now, there are different types of CAD, and I'm going to break these down into a few categories here. I'm going to start with 2D CAD, which would have been 2D drafting. Everything's two-dimensional. Paper drawings, this is what you can do at your desk with pencil and paper. It's good for architectural blueprints, engineering drawings. Also under the realm of 2D CAD, because it went from drafting to include drawing, are vector graphics, SVG images, which I know the laser guys use a lot. And it basically lets you draw an object just using lines. We're still doing everything flat because it's 2D. Then we get into the realm of 3D drawings or 3D CAD. This is where you can look at things from different angles, different dimensions, and it's made from raised images. It's no longer flat. And I love this, where you can spin it around, look at things, take a look at it. This type of CAD I'm going to reference as hard surface modeling. Everything here has flat lines or circles or can be easily measured. It's considered hard surfaces. There's nothing organic or bouncy or not hard. Even your cylinders are considered hard. Which brings us to our next form of CAD, which I'm going to call, it's been called freeform, it's been called organic, it's called digital sculpting. No matter how you look at it, it now falls under the CAD because it's designed on the computer. Freeform is used for all those things that don't have straight edges. Like we see here, you can create sheets and drape things. Freeform or sculpting would come in where you're creating figures and animals, or adding little details that can't be drawn with a square or a circle. Then we have what I call specialized CAD applications. This is where it takes your 3D CAD and comes back and says, we're going to take 3D CAD, but the only thing we're going to do in here is figures. This software is dedicated to making figures and animals and people. That's all this is doing, specialized CAD. Specialized CAD would be your track planning software, your digital painting, animation, your virtual reality and gaming. These all build on the other CAD platforms, but they're specialized to one thing. Advantages of CAD. I kind of mentioned a couple already. The first one is accuracy and precision. Something you couldn't do by hand drafting would be to zoom in or look at closely at to what you're drawing. You're drawing it and you're hoping that you've got it drawn precisely. With online CAD, using it on the computer, you can draw it, but then you can zoom in to look at it to make sure all the little lines match and that you've got it drawn correctly. And as I've gotten older, and I heard it mentioned earlier, as you get to that bifocular age, you like the ability to zoom into things. And I think I do everything zoomed in. I don't think I do anything at regular size. It's also great when you're coming to making changes and updates and working with other people. You can draw the base CAD, you can get a group of people together, take a look at that CAD image and file, and they go, hey, I want this changed, that changed, and this changed. Well, back in the old days, somebody had to go back and redraw that all from scratch because they didn't let you use erasers. With CAD and being able to do it on the computer, you start with the drawing you had, you make a new copy because you want to keep your history, and you make those changes. You don't have to start from scratch. You can just make the changes that are needed and then move on. Additional advantages, again, we mentioned and I showed earlier, the 3D visualization, being able to spin it around and look at all sides. It's important because you can draw something and it looks great from the top, but then when you flip it over, you're like, wow, I really didn't expect it to look like that on the inside or the bottom. Being able to look at all the sides and surfaces is a big plus. It helps with error reduction. Now, I threw this in here because some of the higher end CAD packages have little features in there that will tell you that, oh, you designed this, but you missed a chamfer, or you designed this, but those two lines are too close together. It will actually look at and point out issues with your files. And as artificial intelligence comes in, which is going to be another topic, we're going to see, I see this becoming a larger feature in the lower level packages where it's going to look at it and go, hey, you drew this box, but you only put a chamfer on 3 sides. Don't you need it on the other side too? And we mentioned, and I'm going to mention again, the ease of sharing. I mean, being able to sit here and show you a picture and show people around the world a picture, being able to collaborate just by being able to see it digitally. That is something you cannot do with paper and pencil. Of course, with everything that has advantages, there's going to be disadvantages. One of those is cost. Now, the next segment, I look at different, actually the next 2 segments, I'm going to look at different types of CAD packages. I'm going to include some pricing. And as I was starting my research, I looked at packages that were free, which were great. And then some of the ones I looked at that were highly recommended started at $14,000 a year. And I went, that's a little out of my budget. Also, learning CAD can be challenging. It's easy to sit down with a ruler and a pencil and a piece of paper and start drawing something. If you're not familiar with using a mouse or a keyboard, figuring out what all the little pictures on their screens mean, it can be challenging. And some CAD packages still require licensing by professionals in order for you to actually purchase it and use it. And the other thing that I think is a disadvantage is going to be the over-reliance on CAD. People are going to start with their modeling and go, well, I want to model this. Oh, but I can only draw it in my CAD program and do this. Well, that shouldn't stop you from making that model. Just because you can't draw it in the CAD program doesn't mean you shouldn't model it. And it may come that you're going to need more than one CAD package. For everything that I design, I probably use 2 or 3 different CAD packages. I will use a hard surface modeling. I will use the freeform to finish things off. It's going to be a combination, but I still don't want that to limit people's imaginations. I want people to go, oh, even though I can't draw it on the computer, I can still build that from scratch. And it might be that you can build it from scratch faster than you could draw it on the CAD program. And that's fine too. CAD is just a tool in your toolbox. I get asked what skills are required to use CAD. And I didn't put the most important one on here, which is patience. Lots and lots of patience. Some of the technical skills that you could use or that are needed to work with CAD would definitely be understanding scales, the scale that you want to draw and model in, and the scale that you're actually drawing in. You might decide to draw something full size, so you're drawing a full 8-foot size something, and then later you're going to scale it down. Or you might decide to actually draw it in the scale you're looking at. It's like, okay, I'm going to draw this in 1/64 scale, so my 1 foot equals this, and this is what I need to draw my thing in. Understanding X, Y, and Z, especially when it comes to 3D CAD. One of the things that bothers me is some programs have X and Y, as shown in the picture here, with X and with Z going up and down, up into the air. Other CAD programs have X and Z on the same plane with Y going up and down. So you have to watch these things, but understanding the 3 different dimensions and angles is important, knowing that you're going to have 3 of them no matter which way they're labeled. Also, knowledge of the items that you want to draw. If you have no basic understanding of a figure, you're not going to want to try and create a person from scratch because, arms only bend a certain way. You need to know the limitations of what you can do with an actual person. One of the reasons I've never designed a steam engine in CAD is because I don't know enough about it. I look at the pretty pictures, I see all the parts and it looks cool, but I don't understand enough how they all work together for me to draw that particular object. So these things are kind of important too. Where do I think CAD is going to go? Well, cloud-based CAD is all around us. Again, we're doing the research, and it's great because that way you don't have to have a computer on your desk that's the highest end to run a high-end CAD package. You can have a computer, an everyday average personal computer. You can start drawing, and it is the computer on the other end running that software that has all the processing power. The downside is you have to be connected to the internet, and you have to have a really good connection to the internet. If you've got really slow or spotty, cloud-based CAD is not going to be a solution. Artificial intelligence and machine learning. This, I think, is going to play a huge role. First, in actually catching your errors, which is what I would like to use it for. But one of the things that, which we'll cover in the artificial intelligence, is some places where you put your drawings and they put them online in a library, they're actually using those files to boost artificial intelligence so it can go out there and go, hey, somebody has created this, or 5 somebodies have created this. So artificial intelligence is going to come back, take those 5 models and create its own version and actually create something from scratch. So you just sit down and say, hey, I want a big boy engine, and boom, the CAD program is going to come back and give you a big boy engine. I think we're still a ways away from that. I hope, because that takes all the fun out of drawing stuff. But I think at some point we may get there. Virtual reality. This is cool. This one I would love to do, because you see on TV, and I love watching like some of this old the CSI shows, and they're just sitting there, or the Marvel comics, and you got Tony Stark and he's just waving his hands around in the air, and you got this really cool thing being drawn in the air and you can see it. I would love to be able to do that right now. To do that now, you have to wear, those the funky virtual reality glasses, which when I wear those, I fall down. I am not coordinated enough to draw and do without that. Now, in one of my magazines I just saw, they actually have a monitor to do virtual visualization like this without the need for the 3D glasses or this VR headset. I'm excited about that because I really want to see that happening. I want to be able to sit there and move things around with my hand and stretch and add and subtract. I just think that would be really cool. Generative design. This is something that's already out there in Fusion 360 and some of the higher end. This is where you draw something and you think you've got it drawn and you've got all the piece parts put together and it looks good, because you may need to break it apart to manufacture it or break it apart to install it. And the generative design takes a look at what you've drawn, and then it goes back and it redraws it multiple times until it comes back with a better version. It may come back and say, okay, you can make this thinner and this will still work. You can cut and slice it here. This will make it easier to assemble. Now, like I said, Fusion 360 still has this, and it actually helped me with designing Invisitrax when I designed the gears, because it came back and said, no, this gear ratio would work better than that gear ratio. And if your gear is this thick, it would work better than this. And if it's too thin, it won't work at all. And it helped me determine friction ratios between my gears. I think when it comes especially to interactive designs, this generative design is going to be a plus. And I'm going to try and use it more often with some of my designs, just to see if it can make things better than I can. Because, just because I can do it that way and it works, it's great. There might be a better way. Personally, the best way for me is if it works. And that kind of brings me to the end of what is CAD, because we're just doing a highlight tonight. Our next series, our next one, next weekend, we're actually going to discuss hard surface modeling, what it is, the different types of hard surface modeling, and the different software applications that you would use to do that type of work. On the 26th, we're going to take a look at the organic and the sculpting programs, where you can go in and do the blankets and the throws and the tarps and the soft-sided type objects. July 3rd, we're going to hit and talk about the specialized programs that are dedicated to doing specific things like animals and figures and that sort of thing. And with that, I'm going to open it up to questions about the basic understanding of what is CAD and computer-aided design.
Anybody have any questions for Sherry?
What are the CAD programs you currently use?
The ones that I currently use, I use Tinkercad. I love Tinkercad because I can start something on my iPad and then throw it over onto Tinkercad on the computer. I use, in conjunction with that, Fusion 360, because I can then take my objects that I've drawn in Tinkercad, import them directly into Fusion. They have the thing where I can send it over there and work on it directly. Those are my two key for like mechanical drawings. I use DAZ 3D for creating the bases for my figures and animals when I start doing sculpting. I use Mesh Mixer, which is another soft surface type sculpting application. I've used, and if I was starting from scratch all over again, I would start with Shaper 3D because it's really cool. I love that application. Since we operate on a shoestring budget, I use a lot of the lower free versions of things that have a lot of functionality. I dabble if I need something special. I might pop over to Maya. I might pop back over to SolidWorks. But my go-tos are Tinkercad, Fusion, Shaper, 3D Studio, or DAZ 3D, and Mesh Mixer.
Quite a repertoire.
Like I said, one program can't do it all. You need to have different ones for different specific things that you're working on, which is why we're going to get why I broke it down into the different types of modeling, and then we'll discuss specifics for each application in that category.
Sherry, thank you so very much. Look forward to seeing you again next week.
You're welcome. Thank you.